Hello and welcome. In this video we'll take a more in-depth look at CADWorx plant piping. I'll show you how to connect a piping model to a CADWorx P&ID project database and how to use the information within that project database to place items from the P&ID into the 3D model. We'll also look at some of the more advanced features of the router, including automatic pipe route suggestions, and I'll show you also how to create isometrics using the Isometric module. So let's get started. Okay, now because what we're going to do here is share information between the P&ID and the 3D model, the first thing I'm going to do is set the configuration file for the 3D model to be the same config file that we used with the P&ID project. This is done using the setup dialog box and using the load button at the bottom of the screen. I can load the P&ID config file and use that one here. So I'm just going to browse to my P&ID project folder, and there will be located the project.cfg that was created when I created the P&ID project itself in the previous video. Okay, in that config file I don't have a valid value for the specification directory, so the next thing to do is go to the configuration settings and set the specification directory to the correct directory. Once again here I'm going to use the CADWorx install folder, plant and spec folder, same as before, and save and close. Now the next thing to do when sharing information between the P&ID and the 3D is they must both share the same database. So I'm going to go to set up the live database, and all we need to do here is simply turn the database on, select the database type, and it must be the same database as we use with P&ID. So I go to access and I will select the file and select the P&ID project database and save and close here. Now we see a message which says if I made changes to the live database settings, they will take effect in the next drawing session, meaning I now need to start a new drawing. Now I get the prompt, do I want to start with or without a database? So let's choose with a database. And I just need to now choose an appropriate location to store the file. You must save the file if you're working with a database. I'll just call this pipe 1. Okay, next I'm going to use the structure and the equipment layouts that I created in the previous videos. So I'm going to browse to those and attach them as XREFs. So I'll XREF in the equipment layout drawing at 0, 0, and the same for the structure layout drawing. And I'm going to use these to lay out my pipeline. Okay, next I want to use the line numbering system just like we did in P&ID. So the next thing I want to do is turn on the line numbering system. So let's set the line numbering system on, and we'll add the same categories just like we did in the P&ID, which were service and count. And of course the two separators just like we had in the P&ID. And then I'll move up and move down to reorder the line numbers. And the system, make sure the system is turned on. Okay, now I can set the line number based upon the P&ID. And one final thing to do before we can share the data between the P&ID and the 3D is use the P&ID view screen and select the P&ID project configuration file here. So once again I will just browse to the location of the project.cfg like so, and now here we see a list of all the available items in the P&ID to utilize in the 3D. At the moment we're not ready to use this, so I'll just minimize that and we'll come back to it in a second. First thing we'll do is route the line. So let's open the spec view palette, which we have used before, And on the first button in the spec view palette, I'm going to pick the specification project. And I'm going to browse and use the metric inch specs. And then at this point, it doesn't really matter which spec or which nominal size I choose. We're going to pick that up from the PID information anyway. So I need to pick something to close the window. But before I go and route anything, let's set the piping line number from the PID. So that's done using this button here in the line number section of the CADWorx ribbon. And once you hit the button, we have options here. We can choose process drawings or selecting something from the current drawing. Well, let's choose process drawings. And then we get a list of all the line numbers in the PID. My PID was very simple, so I only have 3 line numbers listed. I'm going to pick this one here, 6-inch ABC123. That then sets the line number to match, sets the nominal size, and picks the specification for us. And now I can start routing. So I'll click on the pipe to start the pipe router. And I'll connect the pipe up to the vessel nozzle, like so. So I'll just use the center O-snap, pick the center point of the vessel nozzle. And then I'm going to come away from this vessel, let's say 900 mil. So let's type in 900. Okay, now I've added that, we can see an issue here. We've got the butt welded pipe connected straight to the nozzle. There's no flange, no connection there at all, which of course is not correct. The reason for this is because of the piping rules. So first of all, I'm going to erase the pipe that I've just drawn and then go to the CADWorx setup and activate my piping rules. So in the setup dialog box, I'm going to the piping rules section. And as you can see here, first of all, I've got the N-type rule turned off, so there's no checking about N-types connection types. I'm going to set that to automatic, so that would prevent me connecting a butt weld to a flange connection. I'm also going to automatically insert gaskets and bolts at flange connections, and the flange insertion rule, I'm also going to use that and turn that on. I'm going to set to automatic and ask CADWorx to use the setting in the piping spec, which in this instance is to use a weld neck flange. I will then save and close, and let's try routing the pipe again. So again, same as before, snap to the nozzle and let's go 900 mil away from the nozzle. And this time I have a flange inserted, the bolts are inserted, and the gasket is also placed as well. So now let's go across, and of course I want to connect to the pump nozzles. Now instead of figuring out or using point filters perhaps to come across in the Y direction so I'm level with the pump nozzle, I can just get CADWorx to figure this all out for me using the connect function in the router. So either hit connect or type C at the command prompt to connect, and then simply pick the point we wish to connect to, which of course was the pump nozzle. CADWorx then will create a box between our start point, which is the end of the pipe here, and our end point, the pump nozzle. Any edge of that box is a viable route, and I can choose to preview the routes either via components or by lines. I'll choose lines here, which I think makes it a little clearer as to what's happening, and we see different routes provided along the edges of the box connecting the 2 points. Any edge of that box, any of the coloured routes, is a suitable option, and I can click on one to preview it. Now CADWorx has also identified that the pump nozzle is a 4-inch, so we need a reducing component in there. I'll pick a 6x4 concentric reducer, and I get a live preview of a suggested route. I'm going to choose this green one secondly, again pick the reducer, and I'm happy with this route. I prefer this route, so once I'm happy I'm going to hit enter to accept the suggested route. So that's the first pipeline routed to the first pump. Let's take a copy of that and route the second pump as well. So I'm just orbiting around here and then just making a selection window, although I don't want the elbow, and I'm just going to take a simple copy, use the copy command, and remember these pumps were spaced 1.5 meters apart, so I'll just copy these pumps 1.5 meters. Copy the piping 1.5 meters. And then to finish off the route, I'm going to take this pipe and use the grip on the end of the pipe, stretch it across, and I'm going to use the perpendicular entity snap to go perpendicular to the header pipe, which then CADWorx will check the branch table, and I get the available options for the type of branch available in the specification branch table. Here I'm going to choose a 6-inch straight T. And there we go, there's my pipe route complete. If I hover over, you can see the tooltips. The piping line number is the same one, matches the P and ID. Okay, I'm just going to hide the XREF panel. And next we're going to move on to selecting the inline items. So in my P&ID I had a couple of valves and a couple of reducers. So I'm going to place these now into the 3D model. So I'm restoring the P&ID view that I saw restored previously. The first thing you'll notice is the flashing red P&ID project label. That's because we modified the project config file by changing the piping rules. I just need to refresh that to reload the config file. Okay, so I see now here in the list, I took two lists, P&ID data on the left, plant data on the right. And of course there is some information in the plant. The reducers, for example, have already been inserted. We'll come back to the reducers in a few seconds. Let's worry about the valves first. So I'm going to filter this list and pick the valves. So I see 3 valves, 2 check valves, check valve 1 and 2, and the gate valve GV3. I can insert these in the model, but what I could also do is I can view the P&ID drawing to check that I'm inserting the correct check valve. So CK1 goes here and CK2 on the other one, on the other pump discharge line. So I know where CK1 should go. I'll click on the insert button and locate CK1 and position this where it should go. So I'm going to position this down towards the bottom of this discharge line. CK1 has now disappeared from this list. It will be displayed, and we'll take a look in a minute, on the linked tab. But before we take a look at that, let's finish off linking the components. Here's CK2. I've already checked the P&ID, I know where this should go. I'll position this, and let's use the snap on the second valve that we've already placed to line the 2 valves up so they're at the same elevation. CK2 now disappears. That leaves us with GV3, which I can just check the P&ID. Okay, this is close to the vessel nozzle. So again, I'll insert this and locate this along the header line, close towards the vessel. Like so. All my valves are now done. Let's take a look at the reducers. So I have 2 reducers in the P&ID, 2 reducers in the 3D model. I'm now going to link those together. But because the 3D model has already been placed, they were placed during the router, I need to retrospectively link those. So I'm just going to check the P&ID that I'm linking the correct one. And then I can check the 3D model. I can zoom to that valve in the 3D. So, okay, I know that this reducer in the P&ID is this reducer in the 3D. I select them both in their respective lists and hit link. And I'll do the same for the second one. So that's all the valves, all the reducers. There are a couple of items left. There is the a small 4-inch section of line in the P&ID, which I'm not concerned with, and there is the nozzle N1 attached onto the vessel, which I know is this nozzle. It's the only 6-inch nozzle that I have in the model. There's an 8-inch nozzle on the vessel, there's a couple of 4-inch nozzles of course on the pumps, and I'm going to link N1 with the 6-inch nozzle. I'll link those two together as well. All that information is then displayed on the linked page. I can see if there's any data mismatching and so forth. Due to the settings I used when I created the P&ID, there is some data mismatch, but we can resolve that. I can use these buttons here to update information, either push from the 3D to the P&ID or from the P&ID to the 3D. For the moment, I'm okay though. I'm not going to change any of that. So I'll close the P&ID. Now my pipe route is complete, including the inline items which are linked to the P&ID data. Okay, let's finish off this pipeline. I'm going to do that by adding some pipe supports. So as the pipe runs across the steel, I'm going to add a couple of pipe supports where the pipe runs across the steel beams to hold down the pipe and keep it in place. I'm going to do that using the pipe support modeler, which is this button here, which opens up the pipe support modeler palette. There are a number of pipe supports assemblies in the standard out-of-the-box specification project, and I'm going to use a very simple pipe support. I'm going to use the U-bolt from the out-of-the-box assembly. So I'm going to insert the U-bolt, and the insertion of the pipe supports, it behaves in a similar manner to the inline items such as valves that we've already seen. So first of all, you need to pick the pipeline where you wish to insert the inline item. The U-bolt then becomes stuck to my cursor, and I'm going to pick a snap point on the center line of the steel beam to line up the U-bolt with the steel beam. You then need to pick the orientation, which I'm going to have as downwards. And then I'm going to simply copy this U-bolt. And I know the steel is 2.5 meters spacing, so I'm just going to copy 2.5 meters and then hit R for the repeat option in the copy command to place 2 more on the final 2 beams. And there we go, completed pipeline, valves have inserted, all the data is linked to the P&ID along with the pipe supports. So let's close the palette and finish off by creating a isometric drawing. Okay, now the isometrics are generated using the Isogen engine. However, in order to be able to use Isogen, you need to set up and configure a style, which is done using the program called iConfigure. There are a number of template styles, so I'll show you how to create a basic, simple style based upon the template. Of course, it's entirely configurable, however that would be another video. So I'm going to hit this button here to launch iConfigure, which will start up a new program, and your iConfigure will load up, and it will look something like this, although yours will be a little bit less complete than mine. I've already got some styles set up that I use on a regular basis. But let's go from scratch. I'll show you how to create a brand new style. Now, the first thing to do is create a new isometric directory. So there's a hierarchical structure to this. You have an isometric directory. Within that you have a project directory, and within that you have the Isogen styles themselves. So I will hit this button here to set up a new isometric directory. And I'm going to locate this into my CADWorx evaluation folder. And I've created an isometric subfolder within there. That will then display in the tree that isometric directory, and it will also enable the new button to create a new project. Which brings up a small dialog box here. I can name the project folder, and because you must have at least one style within the project folder, the available template styles are also listed here. I'm not going to create all of them. I'm going to untick most of them except for the final basic tick box. So I'm just going to create one new style based upon the final basic template, but I'm going to rename that. And I'm just going to call it CADWorx Evaluation. And then just hit OK. That will create the project and the style within that project. And that's actually enough to be able to create the isometric. Of course, the isometric look, style and content will be as per the template. And if you do want to change any of that, you can hit the edit button to access the graphical interface where you can make any changes that you like. There is a search field at the top, so you can search for whichever settings you want to change. And if you do go to change anything by clicking and going into a specific section, there is a live preview that will appear, so you can see the effects of your changes and how that will change the isometric. Okay, but I'm not going to save any changes there, and I'm going to close iConfigure. I'm done with it. The final thing then to do is run the isometric, and that's very easy. There's two buttons here. You can either run Isogen batch to export multiple line numbers. If you have a more complex model with more lines, you can run each line in a single run, or just a single isometric, which is what I'm going to do using the Isogen out function. Then need to use iConfigure, and you may need to choose to connect to your isometric project by clicking connect and then browsing to the isometric project list.xml file. Once you browse to that, these drop-down lists will be filled in with the isometric style that we just created. And that's it. Next, I just hit OK. And all you need to do is now select which components do you want to run the isometric for. So I'm going to just select on screen. You can pick from line numbers, but I'll select on screen, and I'm just going to grab everything. Anything that's not a pipe component will be ignored. So it doesn't matter if you catch the steel or the pumps or the vessel in your selection window. And that's it. The isometric export has been completed successfully. One plot file has been generated. I can open that plot file and take a look at the results. So here's my isometric, fully dimensioned, all components shown, and a full bill of materials labelled in the isometric. So there we have our model complete, our pipeline is complete, and we've generated our isometric drawings. Why not take a look at some of the other features of the router, or check out some of the additional grips to see how they can be used to edit components. Remember though, if you do have any questions, please don't hesitate to contact us.